My name is Omer, and I want to start this session with showing some gratitude. First, to all the people who work really hard, so we all could enjoy this conference, all the volunteers and all the people who work really hard on it. So thank you for all your work. Yes, they definitely deserve some clapping. And second, I want to thank the organizers who chose me and let me be here on this stage. So thank you. It is a huge honor. Can Kubernetes keep a secret? This is the question I want to answer today. But why do we even need Kubernetes to keep a secret? Raise your hand if you ever had to deal with credentials in code, something like client credentials, API keys, tokens, certificate, password. Come on, raise your hand. Don't be shy. Yes, we all had to do it sometimes. And usually when you have to deal with such kinds of credentials, you need to tell them securely to the platform running your code. And make sure that only this platform will know these credentials, so your application will have to use it. And this is usually a highly sensitive type of information, so you need to keep them really secure. Different platforms have a different solution to this problem. And today I want to focus on Kubernetes. And I want to ask how we can pass such a secret to Kubernetes and make sure that only Kubernetes will know it. But before I answer that, I want to do a quick introduction of myself, where I'm coming from, so you can understand my credentials and how I get to answer this question. So this is me. Yes. As you can see, I was a computer geek from a really young age. I'm not sure, I think it's 8 or 10. And I like to build things, I like to code, and I was fortunate enough to do it professionally for the last 8 years. In the last 4 years, I'm working at Soluto by Asurion. It's a local company. I started there as a developer, and I did the shift to AppSec 3 years ago. At Soluto by Asurion, our mission is help everyone enjoy the technology they have, making sure that all the people will get the most out of what they have. And we have millions of users trusting us with their data. And we need to make sure to be trustworthy to their trust. My job is DevSecOps, or as I see it, helping everyone to write a more secure code. And beside all that, I'm also a really fan of OWASP, involved with a lot of projects. One of the leaders of Glue. Glue is a tool that helps integrate tools into the CI/CD. So if you want, come talk with me later about Glue. I have stickers, and I will be happy to chat about it. So I started by asking how we can tell a secret to Kubernetes. But who is the person who needs to tell the secret to Kubernetes? The way we work at Soluto is something I like to call super devs. Super devs are devs who have full responsibility of their application. They write the code, of course, but are also responsible of deployment, and deployment with all the things it includes. And finally, they are also monitoring. And by monitoring, I mean the person who gets the call in the middle of the night is a developer who writes the code. And this is how we work at Soluto, and we really love it. But super devs need help. They can't do everything by themselves. And they need help with tooling that will help them make less mistakes and ensure best practices and all that. And this is why we have a DevOps team at Soluto, which I'm also part of. And our mission is helping these super devs to do their job the best. Now, this is why we're such a fans of GitOps. GitOps, if you're not familiar with the term, is the idea of doing operations using Git. Let's see an example. So this is an example of how you can do GitOps deployment to Kubernetes. So we have the developer, and we have Kubernetes cluster running there. And now the developer produced 2 things. She produced the code, and she also produced manifest files. Manifest files are just files describing the resources she needs. So she can put all this on GitHub, for example, and then some magic happens, which we'll not talk about right now. And there will be resources created for these resource files. In this case, we will have 2 pods. Pods is the basic work unit of Kubernetes. It's like a container. And don't say anyone I say pod a container, but you can think about it like a container that's running your application. So this is how a GitOps deployment of Kubernetes works. And we spend a lot of effort at Soluto in the DevOps team to make this flow as seamless and easy as we can. But there's one thing missing here: how we can manage secrets. Like it's not there. And ideally, we would like to find a solution that will allow us to add the secrets to the flow. So this is where we started to look on how we can find a solution that will allow us to just put the secret in Git without compromising on security, because security is important. And we started to look on different solutions. And today I want to share with you the journey we did at Soluto until we find a good solution that we are happy with. So let's talk about what we want from such a solution. So first, as I already say, we want it to be a GitOps solution. It also needs to support Kubernetes. I don't want to take an existing solution and adopt it to Kubernetes. And finally, of course, I want it to be secure. Otherwise, I can't use it. And it's a highly sensitive type of information, so it's really important to make sure it's secure. And here I wanted to have something I like to call one-way encryption, meaning once the secret is encrypted, you can't decrypt it back. It can be decrypted only on the application. This reduces the attack surface significantly. And this is why I want that. And this is also important to say that for the scope of this talk, I'm not going to discuss anything related to the pod itself. I'm not going to ask questions like who can SSH into the pod, or what is running there? Is what is running there writing well? Does it can leak the secrets? All these are really good questions, but out of the scope of this talk. So with all this in mind, and after a really long introduction, let's go. I invite you to join the journey we did in the effort to try and find a good solution. So the first solution we looked at, not surprising, is Kubernetes native solution. Kubernetes has a native solution for secrets called secrets. And they put a lot of effort on creating a really good object that are intended to hold such sensitive information, like all the things I talked about before. And they even promised that it's safer and more flexible. So I guess we can trust them. And if we go back to the list of the requirements, hopefully there is GitOps, because Kubernetes supports GitOps. There are manifest files that you can use, like I showed before. It's Kubernetes native because it's by Kubernetes. And it's secure because they put a lot of effort, and they say in documentation it's secure. So I guess we can trust them. So I was like, OK, my job is done, right? We can go home. End of talk. Thank you, everyone, for coming. Well, let's take a deeper look. And to take a deeper look, I think I want to look on two aspects. First, let's talk about how we can produce these secrets, how the super devs can produce them. And then I want to talk on the second side of how we can consume this secret from our application code. So let's start with producing. The most naive approach, like anything else we do in Kubernetes, is using file manifest. We have the kind secret. Oh, that don't look good. It's look good on my machine. And we have the name. And then you can see the key value. Someone noticed something weird about the values, something that might not be a good idea? What? It's encoded as? Yes, it's base 64, and I'm sure, yeah, very secure. Now, if you read the full documentation of Kubernetes secret, you get to the section called security, which no one beside AppSec geek like me bothered to read. And they say things very, very interesting about how they make it secure. And then you get to this paragraph, which basically say, don't store secret manifest files in source control. It means they're compromised. And then we get to the line that I'm sure you all heard at least once in your life. Base 64 encoding is not an encryption. That's complicates things a bit, and we need to find an alternative. So at that point, we go on a very naive approach, which I'm sure some of you tried. Just tell the developer to create the secret manually and put them on Kubernetes by hand. Not good, very error-prone, and the developers really hate that. So we start to look on ways to scale this and find a better solution. And there are various solutions that let you create the secrets we saw before, just in the encrypted form. So the idea is to create secrets that you can commit to source control by encrypting them. And it's transparent to the application because there is some magic happen that takes the secret and decrypt it to regular Kubernetes secret. And there are multiple solutions like ham secret or sealed secret, which I'm sure some of you heard about them. So let's take a look on how a sealed secret looks like. This is a sealed secret. Oops. This is a sealed secret. And you can see this is the same manifest as before, this time in JSON format. And we have the kind sealed secret, and we can see there is encrypted data, full with a really long encrypted data. No, it's not by 64, it's encrypted, and I think it's RSA if I remember correctly, but I'm not 100 sure. So this looks really impressive, right? And maybe this time we can use it. Well, there are some issues with that. And the first issue is key management. After all, we need to talk about how you encrypt the data, because if you don't encrypt it well, you did nothing. So sealed secret, the way it works is that you have one key value pair on your cluster, and it's not that secure, and you don't have any HSM protection for these keys. Helm secret is a bit better. It's integrated with a tool by Mozilla called SOAPs, which has support for AWS or GCP, so it's a lot better. But it's also important to talk about coupling. Sealed secret has coupling to a specific cluster. So if you have multiple clusters like us for redundancy, you need to start syncing keys between clusters. Not fun. And Helm secret is even worse because it's coupling to a specific way of deployment. If I move from Helm to Pulumi, for example, I need to switch the entire way of encrypting. Not fun. And finally, and this is specifically true for Helm secret, in Helm, anytime you want to change a secret, you need to decrypt the entire file. It's really hard to do one-way encryption. So I talked about producing, and producing is imperfect. Maybe consuming is better, so we can live with the issues of producing. The most naive approach to consume secret is using environment variables. We have the secret manifest there, and this is a manifest of pod. This is how we define a pod on Kubernetes, and we have the image, Redis, and the name, and all the pretty things. This one is how I define environment variable for a pod. And here I say I want an environment variable called secret username, and I take it from the secret called mySecret and the key called username. So the value there will be the value of secret username, decoded. Really simple, really easy to use, with one small problem. There is a huge dispute whether it's a good or bad idea to use environment variables for sensitive information. And I try to put some argument there because there are good arguments to both sides. Don't bother read it. There is a lot of information here, and I put the slides later on Twitter. This is just for reference. But I said, OK, let's see if there is a dispute or wide agreement. So I put this Twitter poll, and yes, I had a really embarrassing grammar mistake there. This is what happened when English is not your native language. Anyway, this is what you can see that there is no wide agreement. Most of the people think that it's not that good idea, but there are a fair amount of people who really like environment variable, and there are some people who really hate environment variable, like Liran or Jan. Yeah. So if you like them and you don't want to use environment variable for sensitive information, the second way is to consume them via volume mount. So we have the secret like before, and here I define a mount for my container. So I say I want to mount under /etc/foo this secret. And what will happen is that I will have two files under /etc/foo, one with username and one with password. Looks simple, but the more keys you have, the more files you have, and you need to start reading multiple files from your application code. Not all languages have good support for it, and it's not that fun. This is why usually, like we did, you end up doing the following. You create a configuration file in JSON or any other format. You pass it to a base64 encoder, and you put it on a secret. So we have one key there with the base64 encoding of this file. And it means that anytime you want to modify this file, you need to go to the secret, base64 decode, editing, base64 encode, new version of the secret. Cumbersome, error-prone, and not fun. By the way, is someone here working like that, like we did in the past? No? Oh, OK. Good to know. We're not the only one. So at that point, we understand that secrets is not really good, not something we can use. Not from producing side and not from consuming side. And if we go back to the requirement, we saw that GitOps is not that simple. It's Kubernetes native, of course, and secure is also depend on how you use it. So I understand we need to keep looking and try to find better solutions than Kubernetes secrets. And look for existing solutions out there. So we started to look on different solutions for secure key value storage, in this case, HashiCorp Vault. It allows you to create storage for key values where the values are stored encrypted and kept really secure and all that. And it has native Kubernetes integration. meaning my application don't need secret to connect to the vault. If I will need a secret to connect to the vault, I was back where I started. And utilities that create configuration files from vault. So in my code, I just need to read configuration files. And the workflow looks like that. The user put the secret in the vault under /my AppSec super sensitive, and my pod can just read it like I showed before. This is really impressive, and we started to look on it because it sounds like it can solve all our problem. But let's again take a deeper look. So this is the workflow, but there is one thing missing here, which is access control. I need to have to create the proper access control so she can write to /app/my sensitive, but not read. I need that the pod will be able to read, but not write, so it will not change the data. And finally, I need to have access control for the user to grant the pod permissions. For example, if now she needs to create a new service, this new service needs permissions to read things from Vault. These are 3 types of access control that I need to create, and I need to find a good way for the developers to manage them and make sure that we follow all best practices and less privilege and all that. And of course, it's not a GitOps solution. We now have 2 places where, which represent what happens in production. Why it looks like that? Damn, I missed that somehow. Don't edit slides the night before the conference. This is what will happen. Anyway, we now end up with 2 places where, which represent what happens in production. We have Git, which have the manifest files, and Vault, which has the secrets. So there is no one source of truth. And if you get a fan call in the middle of the night and you need to try and investigate what happened and if something changed in production, you need to look on 2 places. Not that good. So this solution is imperfect, and especially if you think about deployment. For example, at Soluto, we don't use Vault currently. So if you want to use Vault, you first need to handle deployment. This is what I talked about, separate storage of that, and no single source of truth. And the external permission model, sorry. And then there is the point of deployment. Because if you're like us and you don't have a deployment of Vault existing, you need to make sure you create a secure deployment of Vault, because if it's not secure, there's no point of using it. And this point, it's important to remember that there are good cloud vendor alternatives, which make the deployment a bit easier, but you still need to solve the problem of authentication and authorization to the Vault. There's the problem of the access control, which I talked about, and especially it's create another place of access control. You have Kubernetes resource-based access control, which you need to manage, and now you have another one totally external to Kubernetes. So if you go back to the requirements, we saw that it's not a GitOps solution. It's Kubernetes native, and it can't be secure. It really depends on how you deploy it and how you use it. So at this point, we were in a severe problem. All the existing solution was not really good, and we couldn't find a solution that we were really happy with. And we tried to keep looking and look on different tools that let you put things encrypted in Git, but none of them look like something we can use. And I was personally really disappointed, and I just want to keep using, like with the portal, putting the secrets there manually, and it's look a bit better than other solutions. But then one day, while working on totally different project, I had to work with Travis encryption, Travis secret encryption. Someone had a chance to work with Travis encryption. So the way it works, you can create an encrypt a secret for your application, and only Travis will be able to decrypt it. And it's really secure because you can put it on public GitHub repo. So they did a really good job there. And when I saw that, I was like, this is really amazing. Let's see if we can build something like that, but for Kubernetes. And this is how Camus born. It's Travis encryption solution, but for Kubernetes. Someone here speaking Hebrew? Good, so I can say what I want. You might wondering what Camus is. So Camus is a word in Hebrew, which means secret or hidden, which what Camus is doing. And now it's time for a demo to see how Camus work, and then we talk a bit more about how Camus help and how it's different from existing solution. So let's see the demo. Okay, no, this is not. Okay, cool. It's going to be hard to do it that way. Okay, so I have a Kubernetes cluster running on my machine. Boy, it's going to be so hard. and I have 3 things running on it, 2 for Camus, 1 for encryption and 1 for decrypting, and 1 example app. So now let's take a look at the example app. It's so hard to write when you don't see what you're doing. OK, but for some reason this works. OK, and let's refresh this. OK, cool. So we have an example app. And the example app is written in PHP just to show that Camus supports any stack, including PHP. And what the example app is doing is it reads secrets from a configuration file, say secrets/config.json, and print them to the browser, because this is what you do with secrets, right? You print them so everyone can read them. So let's see how we can. It's not working right now because it don't have the secrets. So let's use Camus to pass the secret to the application. The way Camus works, very much like Travis' encryption solution, is that you encrypt a secret for a specific application, and only this application can decrypt the secret. And the way we identify applications on Kubernetes is using service account. Service account is a Kubernetes object that basically gives identity for a pod. And if we go back to Kubernetes, I can do kubectl describe deployment Camus example. And if I got this right, I need to do that. OK. Not get, I want describe. OK. So this is the deployment. This is how Kubernetes deployment look like. And you can see that here we have the service account. So now I can encrypt a secret that's clear, so we can see what's going on. And I just go up because it will take me too much time to write it. OK. So yes, you can see that I use Camus CLI, and I told it that I want to encrypt a secret, super secret, another typo, to the service account called. Yeah. Don't type when you don't see the screen. It's too hard. Service account Camus example app, namespace default. The service account Camus example app exists in the namespace default, and I paste it Camus URL. And let's remove this for a second. OK. So this is going to run now, and it's going to create. It started to work, but it's refused to encrypt because the URL it's HTTP, not HTTPS, and the CLI tried to protect us. So I'm going to tell the CLI I know what I'm doing. Let me use insecure URL. Yeah. OK, and now it's not refused to work with insecure URL, and we got an encrypted data. Now I can take this encrypted data if I found the mouse. OK, here's the mouse. And to use it, I can just put it in a config map. A config map is like secret. It's a key value store, but for non-sensitive information. So for example, let's call it token and put it here. And the last thing I need to do is I need to add to my deployment an init container. Init container is a special kind of container that is running before any other containers on the pod. So here, Camus init container will decrypt the data from the config map and put it on a configuration file. Oh, this is so hard. OK. Now we can save this, and we can save this. So here it's like committing to Git. Because it's encrypted, I can commit it to Git. And now I can run kubectl apply, which is the same as deployment. And this will apply the changes. Cool. And now when I do port forward again, and I go to my app, hopefully it will have the secret. Cool. So this just worked, and my application have a configuration file. It doesn't need to be aware of Camus. Questions about the demo? Something was not clear? Yes?
Yeah, so one thing that, oh yeah, I've got a mic. So one thing that occurred to me there, the plain text secret is going to be sitting in the shell history, right?
Yes.
So that's one thing to be aware of, I guess.
Yeah,
So maybe if you're doing it on a dev machine, you just have to be aware to like,
so the CLI
figure out your bash history or whatever.
It's a good point, and the CLI, like many other CLIs, support reading the secret from a file. like you can do with many other tools, just to protect this threat.
You can preface your command with a space, too.
Other questions? While PowerPoint try to return, because it's take a lot of time to PowerPoint. OK, other questions? Cool. So let's go back to the requirement. We saw how Camus supports GitOps, Kubernetes native. I showed how it's transparent to the app and all that. And the last thing I need to talk about is secure. Does Camus secure? And I hope you ask yourself now. So let's talk about Camus security. So the first thing I want to talk about is Camus permission model. We spent a lot of effort making sure that Camus by default is secure, and you don't need to worry about configuring a permission model each time. So any user can encrypt, but no user can decrypt the data. There is no admin role or something like that that lets you decrypt the data. Once you encrypt it, there is no way to decrypt it back. The pod, for example, can encrypt because we don't care, and the pod can decrypt a secret only if it was encrypted for the service account used by the pod. So even if we have a compromised pod, it's very limited what it can do. It cannot decrypt secret for all the application, only for the specific pod. Now let's do a quick threat model to Camus. I already talked about the fact that we have two APIs, one for encryption and one for decryption. The user sends a secret to the encryptor, get it encrypted back, put it on GitHub, magic, Kubernetes. The pod talk with the decryptor, get the value decrypted back. So let's start and look on each one of the components here and talk about threats and mitigation. And I want to start with the user. So I show how the permission model creates a secure by default deployment. There is no need to think about how I create less privileged permissions or all that. And I also saw how the security features of the CLI. It's enforced HTTPS, and it had support for certificate pinning for extra validation and protecting from man in the middle. And that was a really good point about the file. I need to add it here. Let's talk about Git, how we can making sure that even if you had the Git repository, you cannot decrypt the data. So first, we use a military-grade encryption algorithm. I always wanted to say it, so now I have the opportunity. But it's a really secure solution. We're using, Camus has a pluggable encryption solution for encrypted the secret. So Camus can use in-memory AES key. This is the deployment you saw, but it's far less secure than using Azure Key Vault or GCP KMS. These are the two different backends we are supporting right now. Both have support for HSM, and Azure also has support for IP filtering. So even if you have the secret, it's really hard to decrypt it back without going through Camus. And I talked about the permission model and the one-way encryption. So again, even if you have the secret, even if a hacker was able to compromise the Git and get the secrets, she will find it really hard to decrypt them back. And now from the pod point of view, I talked about the permission model, how it helps us to mitigate that. And the way we work with the init container is that the init container and the application container are sharing mounted volume. And this mounted volume is of medium memory. So the decrypted value are never written to the host disk, only to the memory, which is more secure. And finally, let's talk about Camus API. So I talked about the separate pods. It allows me to expose only to encryptor to the internet. The decryptor is not exposed to the internet under any circumstance. I will give up. It's too hard work. There is support to add authentication for the encryptor if you want to limit who can talk with it. And there are, of course, security tests that are running on each commit going into Camus and making sure that only quality code is going into master. Now, of course, like in any good threat model, we have some accepted risk. So now let's talk about them. And I want to start with this one. Currently, inside the cluster, all the traffic to Camus is clear text. We decided to go without HTTPS encryption inside the cluster, not outside the cluster. Basically because it's a really hard attack to perform man in the middle inside the Kubernetes cluster running on the cloud. And I had a few discussions with a few people trying to understand how simple it is. It's not. And I really encourage you to go and talk about it.
Is it compatible with Istio?
Yes, you can compatible with it, like with any other. Sorry. Of course, it's compatible with Istio because Istio is seamless. But let's talk about Istio offline because I don't know if everyone here is familiar with Istio. This is why I didn't mention it here. But there are ways to mitigate it beside Istio. So if you really care about it, come talk with me later, and I will share with you how we can solve it. And yes, the second reason we didn't do it is because it's really hard to perform HTTPS inside the Kubernetes cluster and have a valid CA and all that. I spent a few time also looking into that. It's not simple at all. So this is why we decided that the risk is really low and fixing it is very hard. So we're going to live with it. The second thing I want to talk about is pod impersonation. I talked about how you can use the service account to decrypt. It's important to say that in Kubernetes, the permissions are per namespace. Meaning, if you have a way to run arbitrary pods in Kubernetes, you can mount to the pod any service account you want and be able to decrypt the secrets. Now, this is something we have plans to mitigate. For example, forcing any relationship in the naming of the service account and the pod. We didn't do it yet because we didn't get to it, but there are ways to mitigate it. And anyway, this is how Kubernetes works. And the risk is, again, low because if you're in a position when you can run arbitrary pods on the cluster, it's a pretty bad situation. So you can do a lot of other bad things. And it's also important to say that if you're using Kubernetes secrets, you have the same risk. If you can run arbitrary pod, you can mount any secret in the same namespace. So it's the same situation. And finally, and this is something that I'm really upset about, currently the service account has a token. This is how the pod authenticates to the Camus. And this token is never expired. Once the token is created, it exists as long as the service account is lived. There are plans to fix it in future version of Kubernetes, and I'm really looking for it. But again, the risk is low because if a service account token is compromised, you need to find a way to talk with the decryptor. And the decryptor is not exposed to the internet. So the risk is low. It's really hard to mitigate it. And here there is not a lot we can do from the application side. It's internal Kubernetes issue. So these are the accepted risks. And all the things I discussed, we released the threat model publicly with Camus. You can find it on the repository. We use Jerkin format, similar to OWASP Cloud Security, if you're familiar with. It's a way to describe in user stories different threat and mitigation. So you can find on the repositories all the different threats we think about and all the different controls we put in place or are planning to put in place. So I really invited you, check it out. Feel free to add PRs if you find missing threats or controls. We will really appreciate it. And finally, we have security MD. We know our work is imperfect and we're sure there are things we missed. So if there is anything, this is our responsible disclosure policy, and you can find it also on GitHub. So feel free to reach out to us through the responsible disclosure policy, and we'll be happily address it to make Camus safer for everyone. So let's go back to the requirement. We talk about how Camus is GitOps, Kubernetes native, and secure. I do hope that now you ask how can I use Camus, and it's very easy. We have a Helm repository, so using Helm, it's really easy to install it. Check out the installation guide. It's defined how to create a production Camus installation with Azure or GCP backend. And of course, there is a blog post describing most of the things I talked about today, and also how to install Camus. And I put the blog post and the slide and the link to the repo. All is on my Twitter account, hopefully, if Twitter schedule will work. So this is how you can use Camus. It's really simple, and I will be really happy to help you start it. So feel free to come and talk with me later. Let's talk quickly about things we want to add to Camus, because there is always ways to improve. So I talked about how it has support for Azure and GCP. We didn't forget AWS, we just didn't get to it. And we look for AWS users who want to use Camus to help us test it out. We use Azure, and we added GCP for someone who wanted it. It took me around 3 hours, so adding AWS will be really simple. and most of the time was fighting .NET GCP SDK. Don't do it. It's not fun. The next thing is custom resource descriptor, or to say it other ways, to make it easy to create from Camus a configuration file that can be converted to Kubernetes secret. So for example, if you're working with Prometheus chart know to work with Kubernetes secret. So this thing will allow you to create native Kubernetes secret from Camus object and make it easy to integrate Camus with third-party applications that does not support Camus init container, for example. This is something we really want to add because it will allow us to do GitOps everywhere and not only with our codes. The encryption keys that are used to encrypt the secrets currently exist forever. We want to add a feature that will allow for a user to say, this service account is highly sensitive. I want to roll the encryption keys once in a while and build the full user story. We want to improve quality. We have task coverage, which is really good and we are happy with, but we have no way to measure it. And finally, a function as a service. Camus is a perfect example of fast. There is no need to have an API waiting for encrypt request. We just need to find the perfect fast solution for Kubernetes, which I'm not sure which framework is the most stable right now. And I'm telling you that because we want users and we need more people to play with Camus and tell us what's missing for them and help us build these features. We can't do that if you don't tell us what is not working. Wrapping up, I talked about today the journey we did and the solution we looked at when we tried to find a good solution for secret management on Kubernetes. Kubernetes native secret and different solution to create encrypted secrets, HashiCorp Vault, and Camus, the solution we built. And I tried to look on them from 3 parameters, GitOps compatibility, Kubernetes native, and secure. And you can see that different solutions are different in these parameters. For example, Kubernetes secrets is Kubernetes native, but both secure and GitOps is really depend on how you use it and what you can live with. HashiCorp Vault is Kubernetes native and secure. Again, really depend on how you deploy it, but it's not GitOps. Camus is the only solution that answers these 3 parameters, but we build it to answer these 3 parameters. So if it wasn't answer them, it means we did something bad. Questions? Something was not clear? Yes?
Do you have the ability to unmount the volume before the pod goes live?
But which volume?
The volume that you're storing secret.
So if you unmount it before the pod goes live, the pod will not be able to read them. What you can do is from your pod call directly Camus API. I repeat the question. He asked if you can unmount the volume with the decrypted volume. So if you do that, your application will not be able to read the configuration file, but what you can do is call directly Camus API from your application. And then you will have it only in memory and only from your application code and decrypt only when you need. Does that answer your question?
Yeah, it does. Thanks.
OK. Other questions? Great. So I have one personal request. I would really appreciate a feedback about the talk, so feel free to come and talk with me later and tell me what is working and what is not. I would really appreciate that. I started this question by asking, can Kubernetes keep a secret? Now you know that Kubernetes can keep a secret. It all depends on the tool you're using. For us, Camus was a perfect solution, and it allowed our devs to move higher and faster and focus on their code and less on how to deploy it. And it can do the same for you. Thank you.